So we're going to begin with Pythagorean identity today. What does this mean? It's been established in a unit circle in the previous chapter in the book one. So we're not going to read two different books. I'm just going to pick the key points that I need us to use. The idea here is to focus on the proofs, okay, and how to use those proofs. So let's write the dates. Did I turn off the AC? Now I feel so hot. So today is 8th of June. So trig identities. So for today, I want us to focus on the Pythagorean identity and how to use it to prove and simplify if time permits, because we're not going to stretch it beyond a 2 period that we normally have. You know, after that, then maybe we can do double angle today, addition formula, as we call it. Does anybody have the booklet, the formula booklet with them? I think I sent the soft copy. I'll check. So I can see which one is available in the booklet, so we know how much support you can get in the exam or not. But it will always be good if you know them. So the first thing I want us to be able to do is to recall and apply the Pythagorean identity, just like Pythagoras theorem. I'm not sure this is how some people spell it. Pythagorean identities. Okay. And the second, be able to recall and apply the addition formulae. So two things we should be able to do by the end of the lesson. Before I begin, is anyone familiar with trig identity? So I know what to assume and what not. Raise your hand if you're familiar with trig identity. Lillian, who else? Okay, just to
give an example of what a
trig identity, what I mean? Hello, Mr. Chang, what did you say?
Yeah, like, so can you give an example of what a trig identity is?
Okay, so I'll give you an example of what I mean by that. Wait, where's my control? Okay, there you are. Come down here. Sorry, I'm talking to Zoom. I'm okay anyways. So for example, can you see my screen? Trig identity will be used to simplify this, simplify problems like that, will be used to prove this, will be used to show that this is equal to this, will be used to prove this as well. This is one of the trig identities, will be used to solve this, and so on. That's what I mean. Okay, so let's see if some of these things I sent to you is the exam formula booklet, right? Let's find the formula booklet to see if we have it in it. So we know how much to memorize, but there's no need to memorize. Maybe when you're doing your class activity, I can look at that, okay? So, Mr. Cheng, that's what trig identity is about. So let's go back to my screen. Now, One of the easiest way to see this is to look at a unit circle. So maybe we call this section the unit circle. What do I mean by unit circle? Anyone? I've mentioned that before.
The radius is 1.
The radius is 1. Thank you, Leo. A circle with radius 1, okay? If we have a unit circle, of course, on the XY plane with radius 1, so we are talking about this shape, for example. Okay, we'll keep referring to this unit circle, by the way. So this is 1. Now, you will notice that this point P with coordinate XY implies that the radius is X unit away from the origin, right, on the X-axis. And on the Y-axis, you see, if you look at the perpendicular here, that is the equivalent of the Y-axis, right? That is the Y coordinate of that point P, okay? Now, because there's a right angle triangle there, you will agree with me that by Pythagoras theorem, 1 square is equal to x squared plus y squared. Am I right? Now, suppose this point moves from the origin. We'll discuss the movement. I don't want to just waste time discussing that first. Moves anti-clockwise at this point through an angle of theta, either degree or radian, nobody cares. We can actually write our trig ratio that we are familiar with, like sine theta, cos theta, and tan theta. Is that not? What is sine theta from here? Anyone? Quickly, sine theta from this diagram.
Y over X.
Y over?
X.
No, sine theta.
Oh, Y over 1.
Y over 1. Does everybody agree with that? Do we trust Lillian today? Yeah, we do. We always do. So your sine theta is Y. You notice that your cos theta is what? Similarly? Someone else apart from Lillian? Please, I want this to be a two-way communication. So please. Cos X, cos theta would be what?
X over 1.
X over 1. Who is speaking? Who's that? What is that? That's not speaking, that's whispering. Is that Krista? Krista K, is that you? Oh, okay. So you are the whispering girl today. Hello, whispering, whispering. Wait, is Calista stretching? Lazy girl. So you notice that cos theta is X. Then what about tan? Mr. B, can you help us with tan theta, sir?
Y over X.
Perfect. Y over X. So this will give us the first trig identity that we need today. Allow me to write that properly. Y over X. Okay, now you see that Y is actually sine and cosine is cos. What does this mean? It actually means that tan theta, which is Y over X from here, is what now? Sine theta divided by cos theta. So I write that better. So that is one trig identity. Okay, let's stop. Let's stop for a sec. What does an identity mean? Everyone, listen. Talk to me. What do you understand by that term identity? Anyone? Okay, I'll put it this way. Is everybody paying attention? Can you all hear me? Yes? Okay, good. An identity is like a formula. It's an algebraic, maybe not algebra, it could be a trigonometric. It's a mathematical statement, okay? Of course, on two sides, something equals to something in that form. In terms of a particular variable or maybe bunch of variables, but usually maybe one variable in this case, that is always true for all values of the variable. For example, for all values of x and y, do you agree that this is true? Do you agree that this is true? For all x and y. You pick any x and y, you substitute here, they will always be equal. Yes? Then we can say this is an algebraic identity. Does that make sense? Then we say this is equivalent to this anytime, any day. So this becomes an identity. It's different from equation. If you have an equation, you can say 2x plus 3 is equal to 5x minus 1, for example. This is only true for one x value. Do you agree? Only for one x value. So this is not an identity. This is not an identity. Okay? But this is an identity. Does that make sense? A equals pi r squared is a formula, not an identity. Because you cannot substitute a random A and random R and left to be equal to R, right? Do you understand my point? But when you have an identity, any x or y value on both sides substituted make that true. Then you have an identity. So in that case, we say the left is equivalent to the right. So this is a trig identity, the one we have just written. Is a trig identity because for any value of theta, tan theta must be equal to sine divided by cos theta. So the quotient of sine and cos of the same angle is actually the tangent of the same angle. Does that make sense? So this is what we mean by identity. Let's take note of that. So identity number one for now is that sine theta divided by cos theta is equal to tan theta. I'm sure you have seen a joke online. Somebody wrote sine drain divided by cos drain. What would that be? Tangerine. You know the tangerine? That's orange, very sweet orange that people eat. So somebody then put the picture of tangerine here. Okay, so people make all sort of jokes. Then if you want to write cos, yeah? If you want to make cos, do you agree that sine divided by tan would be cos just from here? Do you agree? So somebody made the joke and wrote sine B divided by tan B and put the picture of cos B. Do you know cos B? That popular American, you know the guy, right? Very old man. I think he does some show in the past. So then they put the picture of Cosby here. So it's just, you know, math jokes based on this identity. Okay, so let's take note of that. That is identity number one that I want us to do. So the next two identities will be based on the Pythagorean stuff. Now, from the unit circle, we have seen that x squared plus y squared is equal to 1. Okay? What is x? X is what? X is what? Cos. Y is sine. So here comes another identity, which implies that sine squared theta plus cos squared theta, it doesn't matter which comes first, we just write sine first, is equal to 1. So for any value, for those of us that have our calculator, apart from my quiet friend who left a calculator in school and who uses a Mac, So my emulator doesn't work on a computer. You can use the internet, Krista. Just type scientific calculator on Google. Can you hear me, Krista? Okay. Type scientific calculator on Google. I want you to choose any angle of your choice. Negative, positive, fraction, decimal, no matter how big, radian measure, nobody cares. And I want you to type in your calculator, open bracket, cos of that angle, close bracket, square, plus sine of the same angle, close bracket, square, and see if you get 1. You must get 1. So please try it. So that's another identity. So this is called Pythagorean identity because it's the relationship here using the Pythagoras theorem. Do you understand that? Okay. Now, the consequence of these are written below because sometimes you don't need the identity directly. You need the consequences. As a result of this, you agree that sine squared theta is 1 minus cos squared theta. Do you agree? And similarly, cos squared theta is 1 minus sine squared theta. Brandy, do you understand what I'm doing here? Leo, can you say something?
Yes.
Do you understand what I'm doing here?
Mm.
Okay. So, like I said, these are the identities that we have seen, this and this. Any other thing you see is just as a result of that, it's a consequence. Consequence means from that thing, we can deduce this one. So they have 2 now. Now, before we move into the next identity, there are some trig ratios. What do I mean by trig ratios? Anybody? Trig ratios, what does it mean? Karen, what does trig ratio mean to you? When I ask question, 5 seconds, please.
I'm not sure.
Okay, Nakita, how about you?
Is it like the angle and then when you substitute some number inside, like the ratio inside, and then you get the
Okay,
angle?
think of this way. Wait, think of it this way. What does ratio mean to you? Clarissa, what does ratio, the word ratio, when somebody says ratio, what comes to your mind? What does it look like?
Like the numbers will correlate with each other. So if one of them will increase, the other one will increase too.
When I write 2:3, what is another format of writing it? What does it look like? Vena.
Wait, sorry, the Wi-Fi cut out for a bit. Could you
Okay,
repeat
when I write
the
2:3 on the board, 2:3, what other way can I write that 2:3? What other format can I express it as?
You could write it as a fraction. So
that's the point. So when we say trig ratio, what are those things we write as a fraction? That's what we mean by trig ratio. So what are the trig ratios that you know so far? Brandy, give me one. You know this stuff. You don't just know that's what they are called. That's why I'm giving you all this. Krista C. So far, what are the things in trigonometry that we write in form of ratios?
Like the opposite side divided by.
What is that called? You're close. Mr. Chang, you want to try?
Is it sine?
Those are the
theta,
trig
cos
ratios. That's why I said you know them. You are not just aware that's what they are called. Okay? Sine is a trig ratio. Cosine is a trig ratio. Tangent is a trig ratio. Does that make sense? Okay? Because they are the ratio of sides of a right angle triangle. For example, your sine is opposite divided by hypotenuse, isn't it? It's a ratio of opposite to the hypotenuse that we call the sine of the angle in the triangle. So sine is a trig ratio. Cosine is a trig ratio. Tangent is a trig ratio. Does this make sense now? So when I mention trig ratio, I'm referring to the usual sine, cosine, and tangent. Okay? All right. Now, why do I bring that up? Because I'm about to introduce you to 3 new trig ratios. Okay? So follow me to the next table.
Wait, can you go back really quick?
All right, Mr. Go back quick. Now, we have discussed so far these trig ratios, all right? Let's write here trig ratios. Okay, so I'll say before now, we know the following trig ratios. The sine, cosine, and tangents, which are ratios of side in the right angle triangle. In any right angle triangle, my handwriting is a bit messy, sorry. So if I have this, and I have that, and I have this, okay, let's hope that is right angle enough. We can't measure that, Nakita, sorry. I know you want everything measured. So if you have an angle theta right here, by what we know in the past, the side facing that angle, the theta doesn't have to be here. The theta could also be here. So my theta could be here. Okay, so if this is my theta, for example, then this becomes my opposite. This is always the hypotenuse. Anyone that faces the right angle, and the last is the adjacent. When you say adjacent building, next to it. So adjacent sides are these ones. When one is the opposite, the last is the adjacent. Okay, so what we know so far is that sine theta is opposite over hypotenuse. We know that cos theta is adjacent over hypotenuse. And we know that tan theta is opposite over adjacent. That's what we know. Okay, so far. Now we're going to introduce their reciprocals, not their inverse. There's a difference. Their reciprocal is when you turn them like raised to power minus 1. Their inverse is arc sine. They are not the same. Okay, so let's take note. Okay, the reciprocals are going to be introduced now. Their reciprocals, the reciprocals of this, are called seconds, coseconds, as the complement of seconds. We will understand this later. Cosine is the complement of sine because it complements sine. What does that mean? It means if I have sine and cosine, what are complementary angles? Does anybody know? Complementary angles, quickly. Angles that add up to what?
Form 180.
No, that's supplementary.
Oh.
So complementary is what? Try again. Come on. Complementary is angles that add up to anybody?
90.
Say that again.
Angles that add up to 90 degrees.
Good, 90 degree. Nakita, can you give us example of two angles that add up to 90, please. Come on, come on, come on. Two angles that add up to 90.
Angle add up with 90 and 45 times 45 and 45.
Now, to give me two angles that are complementary, which means give me two angles whose sum is 90. That's all. Something and something. That's all I want to hear. And try to make sure they are not equal. Say that again.
Wait. Not equal.
Try, no, because we don't want it to be so obvious.
Oh, okay. Then 60 and 30.
60 and 30. Now, this is what complement means. If this is 60, this must take 30, and they are the same. Okay? You can check that. This is going to be root 3 over 2. This should also be root 3 over 2. You can check that. If you use 45, they're going to be 1 over root 2 each. If this is 30, then this must be 60. Then you get half. Okay? They are always equal like that. If this is 0, this must be 90. That is why sine 0 is 0 and cos 90 is 0. This is why tan 90 does not exist. Let's break it down into fraction. Tan 90 would be what divided by what? Based on what we have learned so far, quickly. Using the first trig ratios, tan 90 would be what? Trig identity, I mean. Using that one. Tan 90 would be what?
Sine 90 over cos 90.
Good. Sine 90 over cos 90. If you check your calculator, sine 90 is 1, cos 90 is 0, which is why tan 90 does not exist. So when we get to the graph of tan 90, the vertical asymptote is at pi over 2. And it's periodic. I'll tell you what periodicity. So you'll be able to connect this to functions when we deal with trig function. Just like we deal with rational function and all that, there will be trig function also. It will make so much sense when we deal with that. So these are some of the reasons. So cosecant also and secant, obey that rule. That's what I'm trying to say. And cotangent. Cotangent means is the complement of tangent. So what happened between sine and cos that I just told you happened between secant and cosecant, and the relationship also happened between tangent and cotangent because they are complements in that wise. Okay, now listen, some people mix this together. Because this guy begins with S, some people feel this is the reciprocal of sine. This is how my teacher told me that year, and it makes so much sense. My teacher, Mr. Mbrandri, gosh, I miss that old man. I should visit him in India someday. He said, look out for the third letter in each of these big words, and that tells you the reciprocal of which trig ratio they are. Third letter here is C, so this is the reciprocal of sine. Third letter here is S. This is the reciprocal of sine. And third letter here is T. So this is the reciprocal of tangent. So when I say sec, cos, cosec, and cot, that is the abbreviation we use. Okay, just like sine, cos, tan. Okay, these are the reciprocal of this one. So what does this mean in essence? It means that sec theta is 1 over what? Everybody. 1 over what? Come on. 1 over cos theta. Please, I need communication. What's going on? 1 over cos theta. Okay. Then cosec theta. Why does that sound like Nakita each time I say it? Cosec theta is 1 over sine theta. And cot theta is cotangent. That's 1 over tan theta. So this is where the clue works. C, C. Third letter S, S. third letter T, tan. Okay? Remember, your cosine is this. So your sec will be hypotenuse over adjacent. Am I right? Your sine is this. So this will be hypotenuse over opposite. And since this is opposite over adjacent, then this becomes adjacent over opposite. So these are the new trig ratios that I want you to take note of. Does that make sense? Now, if we come back to this Pythagorean identity, we can form another two new Pythagorean identities. That's the reason we learned this trig ratio. So from sine squared theta plus cos squared theta is equal to 1. Let's see what happens if we divide through by sine squared. Are you following me? If you divide through by sine squared, I'm going to have sine squared theta divided by sine squared theta. I'm going to have plus cos squared theta divided by sine squared theta. I'm going to have 1 divided by sine squared theta. So, ladies and gentlemen, what is sine over sine? Talk to me, please. Sine squared divided by sine squared? 1. What is cos squared divided by sine squared?
Tangent.
1 over tan.
1 over tan, and that's
theta.
called what?
Oh,
That's called cotangent.
Cotangent. Are you following, please? Ethan seems to be the only one that is talking to me. Maybe you can unmute your mic so that you can talk fast and freely, okay? As long as your background is not noisy. So remember, sine over cos is tan. If we flip it over, cos over sine will be 1 over tan. That's what it meant. Does that make sense? That's what it meant. So this is going to be cos, but square. Because these are square, then this should be square also. Okay? All right, cot squared theta is equal to, what is 1 over sine square? Somebody else not eating this time around. Come on, come on, come on, come on. 1 over sine square. Guys, you are wasting time.
Cosecant.
Cosec square. Okay?
Yeah.
Cosec square. Just call it cosec. You don't have to say cosecant. Cosec square. And this gives another Pythagorean identity. Okay? Now, this is deduced from the first Pythagorean identity whenever we divide by sine square. Let's see what happens if we divide by cos square. Okay? I'll say also, okay, similarly, for example, from sine squared theta plus cos squared theta is equal to 1. Oh, lest I forget, this is the identity, yeah? But we can actually get the implications. You know, just like we had implication, these are implications. Do you know what I mean by implication or consequence? Oh, as a result of this, this also happened, right? Hello, do you understand? So we can actually come up with implications for the new identity as well. What do I mean by that? So can you give me 2 equivalents of this? Anyone? 2 implications of that. Guys, I don't like how this class is quiet and I'm just talking to myself. I'm getting frustrated. I have to tell you the truth.
Cot square theta equals cosec square theta minus 1.
So one implication is that cot square theta, that is when you make this the subject, right? So this implies that cot square theta is equal to cosec square theta minus 1. Another implication from this.
1 equals cosec.
1 could be on the other side.
Hmm?
You don't say 1 is equal to x. You say x is equal to 1. The number should be the
Okay.
last. Yes.
Cosec square theta minus cotangent square theta equals 1.
So these are two implications from this. Please, I need response. I'm actually getting frustrated if I have to yell and shout before somebody says something. I need response. Thank you. So also from here, we can actually divide just like we did before. We can divide by cos square. So if you do not have your formula sheets and you know sine square plus cos square is equal to 1, I'm showing you this so you can derive the rest yourself. That's the point of this. So basically, sine squared theta divided by cos squared theta plus cos squared theta divided by cos squared theta, 1 divided by cos squared theta. Can someone who has not spoken, please tell me what this gives now?
Tan square theta
Tan squared theta, thank you, Karen.
plus 1
Plus 1
equals cosec theta, cosec square theta.
cosec as third letter S.
Oh,
It's very tempting because it starts with C. So which one is it?
second.
Sec squared. Good. Okay, it's very tempting. That's why I gave you that third letter trick. Okay, good job. And someone else who has not spoken should tell us two equivalent statements from this.
Sec square theta
This means, is that Leo? Good. Yes, sec square theta, yes.
minus tan square theta
Perfect.
equals 1.
And another equivalent relation.
Tan squared theta equals to sec squared theta minus 1.
Perfect. So these are two equivalent statements from this. Okay, so these three are the Pythagorean identities. From here to the others, they are Pythagorean identities because they are derived from, just like Pythagoras theorem. Do you get my point? Just like from here. Now, how is this used? Let's see. Take you all to the book. Can everybody see my screen? I'm sharing the book now. So look at this. For example, this one. Let's see if this audio works. Then I can play this to you. Perfect. So everybody, I need you to listen to the following example. That will save time. Let's go. Do this if you can hear.
Can hear.
When we defined the sine and cosine ratios using the unit circle, we used a right-angled triangle with hypotenuse length 1. Using Pythagoras' theorem, we obtained a relationship between the squares of cosine theta and sine theta. This relationship is true for all angles theta, and we call it the Pythagorean identity. There are many rearrangements of the Pythagorean identity, which we can look to use with trigonometric expressions. Look at the expression in part A. You should notice the common factor too. Can you use a rearrangement of the Pythagorean identity to simplify the other factor? The factor can be simplified to cos squared theta, and the expression is now in simplest form. Now look at the expression in part B. You should notice the common factor sine theta, and we can then use the Pythagorean identity. The expression is now in simplest form.
Does that make sense? So this is the implication of that. So this does not need to be proved because we have just done it. Can I ask you to try A, E, and I, like diagonal? I'm going diagonal even though that's not a perfect diagonal. A, E, I. Is that I or L? Okay, that's L. Okay, A, E, I, L. Okay, A, E, I, L. Everybody. A, E, I, L. Quickly. Simplify A, E, I, L. You have all the identities that you need. A, E, I, L. Can send to me on WeChat. Leo, are you done? A-E-I-L. Don't forget that. A-E-I-L. So send everything together, not one by one. I'll send that to the WeChat group with the example as well. So when someone is done with that, I can assign something else. Okay, got some entry. Perfect. Perfect. Good job, Lillian. Crystal C. Lillian, you want to check L again? Oh, wait, so one of you is wrong. Ah, I think it's Krista. Krista C. Let's check the last one.
Positive.
Have you seen it?
Yeah, it's positive.
Yeah, it's positive. So that's the only, and you indicated the minus, so just the positive. Perfect. Good job. Okay, so those that are done with it, I've posted the question because perfect. So here is an example for those that finished. So I'm going to play that for you. Please pay attention. And those that are just sending me work, please do. Maybe everybody can just look at this example.
We have seen that the algebra for trigonometric expressions is the same as for any other algebraic expression. We have collected like terms and taken out common factors. In this example, we will use the perfect square expansion rule. The given expression has the form a minus b all squared, so we can compare with this expansion. We have the square of the first term plus twice the product of the two terms. Remember that the second term is minus b, plus the second term squared. How can we simplify this further? The expression involves the sum of sine squared and cos squared, so we can use the Pythagorean identity. The expression is now in simplest form.
For now, that is the simplest form. When we do what we call the double angle formula, this can still be written one step further. Okay, but for now, this is enough. So if you understand that, please proceed to question 2. Okay, question 3a. I'm just going to leave one gap each. 3ACE, one gap each. Okay, 3ACE. Put that in the group also. I'm receiving your stuff and I will check and I'll give you verbal feedback. So please, apologies if you're waiting for my response. So 3ACE, that's what I said, right? Okay. Then after that, we can look at question 4B. I'll write it, don't worry. For B, for D, B, D, E. Okay, these are just the ones to practice in class. It doesn't mean you can't go further later on your own. Okay, so I'm going to be looking at what is sent in now. If you need the previous example, please indicate. So Nakita, I'm checking your work now. Okay. Let's see. Nakita, the original question has minus at the denominator. Can you see it for L?
Oh, okay.
Yeah, so that's the only thing I can think of as an error. Every other thing is perfect. Good job. Okay, let's go to the next entry. Callista. Callista, can Callista hear me?
Yeah.
Okay, so you have mine. Oh, yeah, you're right. Don't worry about it. You're right. I didn't get enough sleep. Don't worry about it. So Callista is okay. Mr. Chang, I'm checking your work now. Unfortunately, sir, it's not sine over sine. It's sine squared over sine, Mr. Chang.
Oh, sorry.
Have you seen it?
Yep.
So you still have one sine left. Perfect. So that's the error, minor error, of course. Crystal K, checking your work now. Oh, by the way, I've made a decision that the exam will not include trig, so just topic 1 and 2. Is that fair enough? So we don't have to include all this new stuff, okay? So it's just going to be mostly topic 1 will be in the multiple choice part, okay, just to make life a bit easier, mostly. And topic 2 will dominate the second section. mostly. So that's all I can tell you right now. Yes, Christus K, perfect. Ms. V, checking your work now. Perfect. Clary, checking your work now. And it's also perfect. Mr. B. Good. Perfect, sir. Good job, sir. Brandy, I will expect you to tell me how you got the minus sine square next time. Not just write it as negative sine square, which we don't know. I'm going to assume I don't know, for example. So this is what I mean, Mr. Brandy. So you wrote cos square. Can Brandy see my screen? Brandy. Where's Brandy? Is the dude here? Or he just put his picture so we think he's online? You're not saying anything. All right, great. So you wrote from here, you wrote negative sine square divided by negative sine, right? Next time, try to write minus, okay? If I bring out a minus from here, it's going to interchange. Because when I multiply back, it will change the, do you get my point? Then we can see clearly that, oh, this becomes this and minus remains. Don't just jump from here to here. Okay, take note of that, please. So, good job. Here come Mr. Leo. Leo, that's cos square theta minus 1, not minus 2. So I don't know where you got that from. Okay, and I have minus sine square divided by sine. Please, Leo, look at the board.
Which one are you talking about?
L. Question L.
No,
yeah.
you said like -1. Which one?
Okay, so the question I saw here, can you see my board? I saw here 2. You wrote 2 here. At least it looks like 2 to me.
Okay.
Then you factorize minus 1 out, and you wrote 1 inside. Yeah. Even if that was 2, that should have been 2 inside anyway. So now you have minus sine square, and at the bottom you have sine instead of minus sine.
Oh, okay.
Okay, because this minus, Leo, this minus is this one. Okay? This bracket, 1 minus sine square, is here. And that is the reason, 1 minus cos square is the reason you have this. So minus does not change, this just changed. So this has not changed. So now the minus will cross each other. Sine square divided by sine is like dividing x squared by x. What do you get, Leo?
So it's sine.
So it's sine. Perfect. So it's sine.
Okay.
That's the point. Good.
Mr. Daniel?
Yes, sir.
Can I leave now? Because I need to shower first. I want to jump before the class.
Oh, okay. That's fine.
Okay. Bye.
Right. See you. Okay, let's see. Miss K. Karen, you have L as 1. That's not true. Karen, did you see the board? Can she hear me?
Yes.
Yes. Where is she? I can't even see her. Okay, got it. Look at the board. Can you see what I did here? You factorize. I can't see that. Although you got the minus sine square, not minus sine. It should be minus sine square. Look at what you wrote. And as a result, you get sine, not sine square. Have I checked everybody's first question? Because you have to come to school by 1:50 and some people probably need to shower. So there will be no extra time, but I would love to stop the class at exactly 1 o'clock. But if anybody needs to leave early, that's okay. Okay, while the rest of us will continue, then you can see the clip later. Okay, if anybody needs to get ready, you know. All right, so let's see. Are you still looking at the screen, Karen, or can I take it off? Are you still looking at it?
You can take it off.
All right, thank you. So let's go back to the book. We're here. I sent that to the group anyways, so you can actually factorize also, but we don't need this now because we're going to need this technique in trig equation. So this is what we need. More simplification. More simplification. So I would need everyone's attention also here. More simplification. Okay, everybody, please listen to this.
In this example, we are given two expressions involving trigonometric ratios. They are both fractions, and we will look to simplify them by finding common factors in the numerator and denominator. Look at the expression in part A. In the numerator, we take out the factor 2. We have seen in the previous example how 1 minus cos squared theta can be simplified using the Pythagorean identity. However, this would not help us find a common factor in the denominator. So, is there anything else we can do? You should notice that this factor is also the difference between two squares. We factorize it as 1 plus cos theta times 1 minus cos theta. We can now see a common factor in the numerator and denominator that can be cancelled. The expression is now in simplest form.
Does that make
now
sense?
Look at the expression in part B. The numerator cannot be factorized, but the denominator is the difference between two squares. We factorize it as cos theta plus sin theta times cos theta minus sin theta. We can now see a common factor in the numerator and denominator that can be cancelled. The expression is now in simplest form.
Does that make sense to everyone? Come in handy. It will be more, it might also be useful in simplifying, okay? And after this class, because it's already 14 minutes before the end, so you have this.
We have seen that the algebra of trigonometric expressions is the same as for any other algebraic expression. We have collected like terms, taken out common factors, and used expansion rules. In this example, we will use factorization rules. In part A, we have a difference between two squares. We can compare it with the factorization of a squared minus b squared. The first factor is cos alpha plus sin alpha, and the second factor is cos alpha minus sin alpha. In part B, we have a trigonometric expression whose form is also a quadratic. It has the same form as x squared minus 3x plus 2. There are no common factors. The expression is not a perfect square, nor is it the difference between two squares. Instead, we factorize the quadratic by looking for two numbers with product 2 and sum minus 3. The numbers are minus 2 and minus 1, so the factors are x minus 2 and x minus 1. We can now factorize the trigonometric expression by comparison. The factors are tan theta minus 2 and tan theta minus 1.
Does that make sense? So this will come in handy, especially when we do trigonometric equation between 0 and 360, something that will remind you also, and is very, very useful. So I will take a screenshot of this, send to you, But before we go, if anybody has time, please, I want you to do I want to see 2C, no, that's cheap. That's too cheap. Okay, 2C, 2E, 2H, then 3A. Okay, I'll write it in the group. I'll take a screenshot of this first. Of course, there's no compulsory work to be done here, but try as much as possible to do later. After I take the screenshots, we are going to close the class, so you don't have to do it now. That's the point. So for the example, take a screenshot also. And the activity that follow this example are the following. So in that activity, I want you to do 2C, right? 2C, 2E is similar, so there's no need. 2G, let's do G instead. Then H and I. Okay, that's not L, that's I. I just automatically put it in caps lock for me, sorry. Then I want you to try 3B now, not 3A, 3B and 3D. Okay. So it's all sent to the group. Okay, there's our next page.
You also send the whiteboard.
Definitely. That is being recorded automatically by Zoom. Thanks for reminding me. So on the next page, we can attempt 3E. Like I said, this is not compulsory homework. The more practice you do, the more proficient you'll become. Is that clear? So I'll be interested in, I'm just picking the question that might be tricky so that if we need to come together and look at it, we have more stuff to look at. I and J look similar, so I'm going to pick H and J. Okay. So that's that. We couldn't do double angle, but before double angle, we need a compound angle. So tomorrow we'll start with compound angle. Then it will make sense for you to know double angle. So I'm going to take a screenshot of this. We don't need to worry about solving equation yet. I want to combine all trig equations in one class. Okay. Any questions, guys? Questions from anyone? Oh, say my speaker. Can you hear me? Unfortunately, it says something is wrong. Yeah. Can you hear me now? I don't know, the internet just did something to my speaker. I'm seeing something that I'm gonna send to you. If you look at the message by the right corner, it says something about my speaker is not working due to connection. So it's okay, you can hear me now. So make sure you do some practice based on what we have seen so far. Tomorrow we're going to look at compound angle. I'll just give you a heads up what that means. So in compound angle, basically, we're going to go beyond all this. We're going to look at what happens to cos A plus B. And if A is equal to, now this is called addition formula, okay? We look at it for minus, we look at it for sine A plus or minus B also. Now, this was extended that if B is equal to A, then you're going to be dealing with cos 2A and sine 2A in the case of the addition part. Do you understand? Instead of cos A plus B, because these are 2 in 1. If B is equal to A, it becomes this. Then instead of sine A plus B, if B is equal to A, it becomes that. And that is what the textbook referred to as the double angle formula. Does that make sense? That's what we are going to be learning here, double angle identities. So, but we're not going to do that until we can do the addition formula and apply it. So that's what we'll be looking at tomorrow in class, even though it's a single period, but we'll see what we can do. Okay. Without any further delay, I'd like to end the class. If there is no question, any question from anyone? Nope. All right. I'll see you. See you in school soon and see you in class tomorrow. Hopefully there's no rainstorm. Thank you so much for coming online. I'll see you later. Bye.
Bye.